Imagine moving into a new neighborhood, and as you settle in, you start to form connections with your new neighbors. This process is quite similar to how OSPF routers establish neighbor relationships. They introduce themselves and exchange information about their connections to other routers, thus forming a solid network. In this network, hello packets function as handshakes, a friendly gesture to maintain neighbor relationships and detect changes in the network topology. This continuous exchange of hello packets ensures that the connections remain alive and well. As these OSPF routers get to know each other better, they share database description packets or DD packets which function like maps. These maps provide an overview of each router's link state advertisements or LSAs, thereby allowing these new friends to synchronize their routing information. Now let's dive a bit deeper into these LSAs. They are like detailed descriptions of roads containing specific information about each router's links and reachable destinations. These LSAs form the backbone of OSPF routing. To keep things efficient, OSPF routers share database summary packets or DB summary packets. These function like condensed maps, summarizing the LSAs within a certain area, thereby reducing the amount of data transmitted and improving efficiency. This network of OSPF routers can be compared to a city with different neighborhoods representing different OSPF areas. These areas divide a large network into smaller manageable regions, reducing the amount of routing information exchanged and making the overall management of the network more efficient. In this city of routers, we have different roles. We have the backbone router, or ABR, which functions like the city's central hub. It connects different OSPF areas, enabling inter-area routing and summarization. Then we have the designated router, or DR, which is like the community leader of a neighborhood. The DR handles intra-area routing within a single area, reducing broadcast traffic. And just like any good community, there's a backup. The backup designated router, or BDR, stands ready to take over as DR if necessary. Just like a city has security gates, OSPF routers have filters that control which routing information is allowed to pass through. This function prevents unnecessary traffic and improves network security. And finally, just like a city map, OSPF summarization reduces the number of routes by aggregating multiple network segments into a single summary route. This reduces the size of the routing table and improves routing efficiency. To sum up, OSPF routers form connections just like new friends in a neighborhood. They exchange hello packets to keep these connections alive, share DD packets to synchronize their routing information, and use DB summary packets to improve efficiency. They divide their network into manageable areas, have different types of routers for different roles, use filters for security, and utilize summarization to improve efficiency. These are the key points to remember about OSPF routers and their process of forming connections. Just like a well-organized city, a well-organized network provides efficient and secure communication.